Hi everyone, so it's Easy Theory here. So I wanted to do a special video today, and maybe in the future, if there's enough consensus, showing how I actually create midterms and final exams and all that. So here we're going to make a midterm for corresponding to regular languages, usually the first midterm in a class. Um, so the way that I do them is in something called Latex. So Latex is it's basically a markup type language, if you know programming languages, that allows you to do nice mathy expressions really easily and to make tables and it just looks a lot nicer than if you used other things. And it's so much more convenient and a lot easier once you understand how it works. So for any instructors out there, I actually have a little script right here that allows you to read in from a CSV file, where you format the CSV with the first name and last name of all of your students, and it will create a gigantic PDF corresponding to every single student in the entire class. So it will pre-print their first and last name on the actual test like it does here. So the only person in my CSV file is I'm a test, just to see that it actually works. But it actually will pre-print the name in the upper right hand corner of all these other pages. And to help sorting later, if you format the names in the CSV file in alphabetic order, there's a little number in the bottom right that indicates which test it is. So if you want to sort by, say, last name or however you want to sort it, you can just sort by the little number in the right side, and it's a lot easier than having to compare names against each other. So this is actually really nice. So if we wanted to make multiple tests, what I would have to do is I would just make two CSV files and write two different tests. And it will create everything automatically. So it'll just make one gigantic PDF. And if your printer supports it, like the one at my former university does, it actually staples the test, which is actually really, really cool. All right, so how do we actually do this? So I have some sample stuff right here, and if any instructors want some of this, feel free to contact me. My email is in the video description. But so I have some basic stuff at the top. You can obviously change this for your class. Like if you wanted more time or less time or things that are allowed or not allowed. And so here's a table cataloging how I distribute points in the test. Obviously you can change that here and the number of questions and whatnot. All right, so on to the meat of the stuff. So how would I actually make the test? Well, the way that I used to do it, and it may change in the future, is for regular languages, I want to have a question on Dfa and Nfa construction because I want them to actually, when presented with a problem, be able to make a Dfa or Nfa with it. And usually what I would do is I would ask them to make two different DFAs and then another DFA, which is the intersection of the two, which demonstrates the product construction. In conversions, I flip-flop between what I want to do here. So it may be like NFA to DFA or regex to NFA, or the other way around. Or maybe I include two of them and both of them are easier than like one full one or something. But other than that, I want to have them be able to reason about certain things. So if I want to ask them certain problems that I think are interesting and makes them think a little bit and try to reason why it's true or give a counterexample if it's false. I want them to be able to do some amount of proofs, and it's not necessarily just pumping lemma proofs, so that one's down here, save it to the end, but I want them to be able to prove something else. So something that they've never seen before, because they're going to be potentially encountering things that they've never seen before. And then for extra credit, I want to put in something interesting that I think is worth thinking about. So this last question might be harder than all the other ones because it's extra credit, but I just want them to be able to think about something that may be not totally obvious. All right, so let's think of some questions. So I don't have any questions in front of me. I'm just doing this totally off script. So let's see, what would be interesting for a DFA here? So let's do that idea where I had two DFAs and I do the intersection of the two. So what I'm going to do here is, so these point total functions or commands really, I have them created up here. They're just commands to say, it just makes this nice text right here, which says how many points there are. So I say points total 30. So what I want to do here is I want to make an itemized list. So I'm going to do begin itemize. And by the way, the application that you're seeing right now is Text Studio. You can use any other one that you want, but this one has some quirky benefits that I like it autofills certain things for you. So yeah, so here we got to make an item, and I think it would be reasonable to have 3 parts right here, 2 DFA parts and then a third for doing product construction, and have them all be the same number of points. So let's say points 10. So this one's going to be 10 points. Then this one's going to be 10 points again. And then this one's going to be 10 points again. And obviously we're making a test here. So actually, let's just run this. So if I run this, then it's going to produce 10 points, 10 points, 10 points. Okay, so the thing is, well, I could have them all up here, and actually that'd probably be okay. But what I like to do, oops, I was in the wrong thing. Yeah, there we go. So what I want to do is I want to have some spacing in between each of these items. So what the way to do that is with VSpace, or at least the way I do it is with VSpace. So I'm going to put 2 inches in between. You can put centimeters or some other units in there. I just like using inches because I'm American. So I'm going to put 2 inches in between, and I have a clear page right here, so I don't need to put any under this one. Okay, so what would be a reasonable thing to say? So what I usually write is construct a DFA for the language something, and then I'm going to copy that for the second question because it's going to be another DFA. So let's see, I do want a DFA for all strings that contain a particular substring. So let's call this guy L1. And to make mathy symbols, you do $signs, and then underscores puts something subscripty, and then the backslash on the curly braces, you need to do backslash curlies in order to actually make the curly braces. So if I run this, you can see that we have empty curly braces right here. So here I want to have all strings, let's say in A, B, star. So the star command here makes a little pretty star. So I used to actually just put Shift 8, which is the other star. It's not exactly the same symbol, as you can see. It's slightly changed there. I like using star. It just looks prettier. So here, let's do a really simple one because it is a test. Let's say W. And there are several ways to write the word contains. The way that I like to do it is to put a little spacer and then text contains another spacer, let's say AB. Okay, so all strings that contain AB. Gotta put a period on the end because it's a sentence. All right, so let's make another DFA. And I want to do something that's substantially different than this. So here, like any string that contains BA is in this. Yeah, any string that contains AB is in here. So that means there are infinite number of things in here. What I want to do here is I want to have a finite language because I want them to be able to work with finite languages also. So here, again, I'm going to have the same starting block and then star. And then here, let's say, oh, I don't know. So let's say W starts with an A. And then let's see, what would be reasonable? And has length at most 2. I think that would be reasonable. But then the problem is that it kind of jumps over the line. So it's because the text command is basically not processing that it needs to line wrap. So what I usually do here is kind of cheat my way through and get rid of the dollar signs around everything and just leave it as normal text. And this should be okay. Yeah. Yeah, it's a little annoying, but oh well. So now for the third part, I want to do I want to do the product construction of some kind. So let's say we want to make a DFA for, let's say, the symmetric difference. That would be interesting, of L1 and L2. And at this point, students might not know what symmetric difference is. So here I put like a note or a hint or something. The symmetric difference of L1 and L2 is the set of all strings that are in exactly one of L1 and L2. Okay, and obviously the way to actually make DFA for the symmetric difference here is to do L1 intersection the complement of L2, and then union that with the complement of L1 intersection L2. And that'll be all the strings that are in exactly one of the two. Okay, yeah, that actually might be a little hard because it technically involves the product construction twice. Maybe what we should do is, let's see, what would be reasonable? So here are the dilemmas that you encounter when you are a professor and you need to make tests. Let's say that, let's actually not do symmetric difference. It would be great on a homework question, but it's not great on a test question. So let's say DFA for, let's just do one of the two. So let's do intersection of L1 and L2 complement. So cap here, the command is for intersection. Overline puts a little line over whatever's on the inside, and so that's how I do complement. You can do caret C if you want the C upstairs. If you do that notation, this is the one that I use. And so you can either do the product construction in this case, or you can you can just like try to be a little clever and try to figure out what can be in the intersection of L1 and L2 complement. Okay, so for conversions, let's see, what would be reasonable? So I do want them to be able to do the NFA, the regex to NFA conversion. And since we will have an NFA at the end, let's convert that to a DFA. So maybe what we should do here is itemize on two things. So here I'm going to have, actually no, it should not be itemized, it should be enumerate. Note that for a new, I mean technically yeah, the dots are okay, but I like when it has like a 1, 2, not 1, 2, 3, but a A, B, C on the parts. And the way to actually customize the enumerate here is to put an argument. So that's with square brackets, and then the way I do it is with parentheses A. So the A here is saying you start with A, and then you go to B, then C for each subsequent part, and then D, E, F, etc. So you get A, B, C, and it's really easy. So here I want to do the same thing. So let's do enumerate A. All right, so now what I want to do is let's make a regular expression. So the way I usually write this is consider the regex, oh, I don't know. So when I make regexes, I want to have one instance of union, one of concatenation, and one of star somewhere. So I want to do, let's say, 0 or 1, 0, star. So the cup here is union. So if I run this, you can see 0 union 1 0 star. Then convert this regex into an equivalent NFA. And then what I usually write here is using the methods described in class, because I want them to not be too clever about this. I want them to actually think, how would a computer approach this? What is an algorithmic way of doing this? And there's a way that we do in class, and I've done on the channel. Then we need our V space thing again. So let's put 3 inches here. So then now I want to, let's convert the NFA from part A into an equivalent Dfa. Again, using the methods described in class. Okay, and now I have a clear page, so I don't actually have to do anything. Oh, we got to put points here. So let's say this one is, I usually do 15 and 15 on this. So points 15. Let's make sure it works. And it does, super. All right, let's do question 3. So here what I do is, I want them to say whether it's true or false, but I want them to give reasoning too. And the way I do it is I give all the points for the reasoning. So I put some header at the beginning here. So like for the following questions, briefly state whether or not the statement is true. All of the points are for the reasoning. All right, so then let's begin enumerate again on A's. So let's make all of these 10 points. So I'm gonna copy this, points, and let's put some space in between. So let's say 3 inches, space 3 inches. All right, so what would be reasonable? So we know that if we have 2 languages that are regular, their intersection is regular, but the converse is not true. So if I have the intersection of 2 things is regular, it's not the case that the original 2 are regular. So I do want to have at least one false statement in here so that they actually are thinking about it. So let's let L1, L2 be 2 languages. Then if L1 intersection L2 is regular, then L1 and L2 themselves are also regular. And that's clearly false, because you can just have 2 non-regular languages with empty intersection, but their intersection is empty, and so which is regular. But then I want to have 2 actually true answers. Actually, no, there's one other one I do want to include. So I do want 1 true and 1 false, but I flip-flop whether I want 2 true or 2 false. So the one that irks me that students mistake all the time is looking at 2 languages, let's say LL versus this language, which is all the strings in L, but repeated twice. So concatenation, you don't have to pick the same string twice, whereas in this guy you do. So yeah, so I want them to be able to think about this. So if L is a language, then I want this to be a false statement, because there are languages, actually most languages are not going to be equal right here. So I want them to actually think about this. So this one is also false, and to give a counterexample, but I do want to have a true one. So here I want them to also think about, let's say, How about like the minimum size DFA for a language can be smaller than the minimum size DFA. So let's let L be a regular language. Then the number of states in the smallest NFA for L is at most the number of states in the smallest DFA for L. I think those are three reasonably good questions. Oh, so you can see that part C is way down here. So what I usually do is I back off the number of inches, let's say by half, and I try to make it reasonable. Yeah, I think that's reasonable. So I think that's pretty good. So 2 falses and 1 true. All right, question 4. So now I want them to be able to prove some little statement somewhere. Let's see, what would be a reasonably good thing? So, one that might be interesting is the fact that NFAs can have exactly one final state, because all the final states can epsilon transition to that state, to that final state. Whereas there are languages with DFAs that have at least 2 final states. And we actually do one usually in class, which is the set of all strings over 0, 1 that have the same number of 0, 1, and 1 zeros. So what I would do here is, let's have this be in 2 parts. Would 2 parts be good? Yeah, I think that'd be good. So let's begin enumerate again. So let's say, actually before this, let's say let L be a regular language. Then we say let N be an NFA for L. Let's see. What would be an example? Okay, let's do the given example. So let's say we have W in 0, 1 star such that the number of 0, 1s in W is the same as the number of 1 zeros in W. So let's let N be an NFA for L. What is the smallest number of final states N can have for L? And then, so that answer is obviously 1. So here I'm going to have points 15. Actually, I would give 10 here because the answer is basically just one sentence. Then I'll do V space 2 inches, and then item points 20, because it's got to add to 30. Let D be a DFA for L, and then the rest of it is the same. What's the number of files? The smallest number of final states D can have, and this one is 2. So there's no way that you can ever have fewer than 2 final states for this, and the reasoning is that if you had 1 final state, then you must have some loops somewhere, and what you can find is that you will eventually accept a string that you don't want to actually accept. So essentially you have 2 equivalence classes in terms of the strings that you want to accept. The ones that start with a 0 and the ones that start with a 1. And fundamentally those are incompatible with each other. All right, so I think that's pretty reasonable. Maybe more space in that guy. Of course, if you're an instructor, you can change this at will. You don't have to make it exactly this. Okay, so now onto the pumping lemma one. So what would be good? So there's one that I heard really recently that's really, really cool, which is, suppose that we have like a let's say we were trying to write a compiler for a programming language. So if we had like a main function and I have some variables, let's say int a, int b, etc. And I want to have a DFA check whether this is syntactically valid. Well, what you can do is you can show that it's impossible for a DFA to compile all programs to check whether a variable has been declared twice or not. So the argument is, if I have a variable name that has a bunch of A's in it, and then I have right on the next line a whole bunch of A's in this one, then if this does not compile at all, then what that means is that these two these two variable names are exactly the same, which means that essentially we're asking, is this run of A's equal to this other int of A's? So, but the thing is that if we interpreted this program as a string, then the gap between these is not that big. So what I'm going to do is I'm going to have like int b's in here, something like this, to separate the two sets of A's. Although you don't actually have to do that. Actually, this actually shows that it's not context free, but that's beside the point. But yeah, so what we can do is something like this. So what I usually want to do is I want to give some reasoning. So let's suppose we want to build a DFA that checks whether a program is whether a program is let's see, how should I phrase it? Can be compiled, let's say. Can be compiled. Then, for example, a program might look like, let's see. And the way that I usually write this part right here is I use the verbatim. So begin verbatim. And so in Text Studio, it actually changes font color a little bit. So let's say we have something like this, and then 3 A's, int b, etc. And then I'll end verbatim. So when I actually have this come out, oh, I forgot. So verbatim doesn't actually work here. You have to use, you have to load verbatim from a file. So what I'm gonna actually do is to actually leave it like this. But it'll take some finagling to get it correct, or actually to look reasonable. I forgot that you can't use verbatim. Actually, I'll just leave it like that. So I want to actually get this in the center. So what I use is begin center. You should note here that I'm a tech noob, so I'm not really good at a lot of tech stuff. So if you have any suggestions, feel free to put them in the comments. So a program might look like the following string, I should say, because you can interpret all programs as just a gigantic string. So then I'll say let L be the set of all strings in ASCII, let's say, that are compilable. And then what I want them to do is to prove that L is not regular. I used to say to ask them, is L regular? If yes, then give a DFA for it. If no, then prove it. But so many students will think, okay, I'm just going to skip this and try to get a few sympathy points by saying it is regular, so I don't have to do a pumping lemma proof. But here I'm going to actually explicitly tell them so that they they're not led down the garden path in the wrong direction. Yeah, so the basic idea here is I want them to notice that these two runs of A's we can have these two runs of A's be as long as we want. And if it's not compilable, I should actually say compiled specifically if a variable has been declared already. Yes, specifically whether a variable has been declared already. So let's run that. All right, so that, I think that would be reasonably good. Maybe I would add a hint, but I think this is fine as is. All right, so what about the last one? So one that I find interesting is, the algorithm to check whether a DFA accepts infinitely many things, because it's based on the pumping lemma. So what I would do here is I would give basically no hints at all, because it's extra credit. I want them to think about it. So what I want to do here is give an algorithm, let's say, that checks whether a given DFA, let's call it D, has or accepts infinitely many strings or not. And then maybe I'll ask them, what is the runtime of your algorithm in terms of the number of states of D? And there are a lot of ways to, actually, the one that's better than this is checking whether two DFAs are the same. So like if the TA or me has to grade homeworks, what we would have to do is we would have to run EQ DFA, or the decider for it, on the two DFAs. But there's two different perspectives that you can take, which is you can run strings up to a certain length, which is based on the pumping lemma, or you can minimize the two DFAs, and you can, if they are structurally identical to each other, then they must be equivalent. So suppose that the instructor has to grade many homework submissions or involving, I should say, DFAs, and the instructor has a sample solution DFA called, let's say, D solution. And suppose that the observed student DFA is D student. And what I would do is write an algorithm to check if the language of D sol is equal to the language of D student or not. And maybe comment on the runtime of your algorithm. And I don't say anything more than that, because it technically depends on the number of states in the original two machines. Or maybe, I shouldn't say write, maybe outline. So they don't have to provide all the details. I want to see if they actually are able to think about, if I want to check if these two sets are the same, then I just need to check if one is a subset of the other. And what a subset means intersection with the bigger guy's complement. All right, so that makes a test. And if there were more students in this CSV file, where is it? Yeah, right here. So this is just a file in the same directory as where the tech file is corresponding to this. And if there are more students, it will just make this PDF longer and longer and longer. So it's just one big PDF, and you can split it up however you like. So hopefully that was interesting. Leave comments down below. If you want to get this tech file, please send me an email and I can send it to you. Hopefully that was interesting. Leave comments down below. There are other links in the video description if you want to support the channel further. And as always, thanks for watching, and I'll see you next time.